Okay, hello everyone. Welcome to this new video. So today I would like to talk about using Python to generate a list of prime numbers up to a certain value x, which you can choose. So I was thinking about this because in primary school, I was using the calculator to manually key in and just to think about what numbers are prime and to try and generate a list of prime numbers. And so I thought about translating this into code because recently I have learned a bit of Python coding. So I have decided to do that. And also because I think that this is quite a short and simple function that I wrote to generate this list because it uses a few shortcuts. So let's just jump into it. So first, we look at the function primes up to a certain value x, which the name already makes it quite obvious. You want to generate a list of all prime numbers up to that number. So what we do first is we assert that it must be an integer and it must be more than 2. And now what we do is we iterate from I equals to 3 all the way to I equals to x, which is the number that you want to stop at. So first we create a prime list, which is a list of just one number so far. It's just 2. But as we go along, we will add more prime numbers into this prime list. And what we have to do is to assume that 2 is already a prime number, but that's easy enough to check using our normal mathematical methods. So this while loop over here, line 14, while I is less than or equals to x, is just a way to make sure that whatever is written down here continuously loops until I reaches x, and then after that it stops. So it goes from 3 all the way to x. So now we look at this for loop, line 15 for prime and prime list. So what it does is it looks at every prime in the prime list, and as long as I is divisible by any prime number, so what happens is by definition, it is no longer a prime number. For example, 6 is divisible by 2. So what we do is we set is prime, line 18 to be false. It's not a prime. We break out. And then what we do, line 27, I plus equals 1. We look at the next number, which is 7 in this example. So you don't have to do anything. If it's not prime number, you don't have to add it to the list. You just break from the for loop, and then you add 1, and then you look at the next number. So when do we stop? So this is the way that I found out, and it can save quite a lot of time. You don't have to check through the entire prime list actually. You only need to check until the square root, the prime number is greater than the square root of I. So why is this so? We can use a contrapositive, which is proof by contradiction. So if both prime factors were greater than the square root of I, then multiplying both of them together would give you a number greater than I, and that is a contradiction because it must be equal to I. And hence, if one number is greater than the square root of I, the other number must be smaller. They are inversely proportional to each other if you think about it. So once you check through all of the prime numbers that are smaller than or equal to the square root of I, you can say that, okay, I don't have to check anymore. I know that this is a prime, and then you can break out of the loop. So now we look at this part, line 25. If that number is indeed a prime number, if its prime equals true, what we do is we append I, the number, to the list of prime numbers. And then for subsequent checkings, we include that prime number in our search list. So the prime number starts with only 2, then it comes as 3, and then 5 and 7, and so on. And then after that, finally, line 28, we return the prime list. So let's just see how it works over here by printing all the primes up to 1000. Let me just run this now, and you can see it goes from 2 all the way to 997. It has very quickly printed this all out. So if I use my calculator, it would have probably taken me a few hours, and actually it can do even more. I can print primes up all the way up to 10,000, perhaps even more. But see, even for 10,000, very quickly, it generates all these prime numbers. And yeah, so it is quite a fast method. And one question I have for you guys is, what is the order of this using a big O notation? I think it lies somewhere between O of n and O of n squared, because you only have to iterate up to the square root of, you only have to iterate for prime numbers up to the square root of I. So you don't have to iterate through the whole prime list. So it's definitely faster than n squared. But there are two iterative loops, the while loop and the for loop. So it's more than the order of n. So I leave it up to you to think about it. I am still trying to figure out how to go about doing this. But yeah, this is a fast way of generating prime numbers, and it works by only checking whether the number itself is divisible by prime numbers and only checking up to the square root of I. So those are the two methods to generate this much more quickly than the usual method. All right, that's all I have. Thank you for watching.